Welcome to a PDF Association webinar on advancing or on the future of 3D in PDF in regards to JavaScript. My name is Duff Johnson. I'm the CEO of the PDF Association. I'll be the moderator for today's event. And just a brief word about the association. PDF Association is an international nonprofit, and its business is managing the specifications and ISO standards around PDF technology. 3D is a technology that it has a place in PDF, and that's what this discussion is going to be all about. So I'm very happy now to turn it over to your webinar host, Patrick Gallot from Datalogics. Patrick, take it away.
Okay, well, let me share my screen. Okay. All right. Everybody see that? Okay. As Dov Johnson said, I am the chair of the PDF Association's Rich Media Technical Working Group. My day job is the technical lead for the Datalogics support department. And for the panel, I'll be joined, actually for part of the presentation, I'll be joined by Phil Spreier, customer engagement lead for Elysium, who I'd say was largely responsible for the creation of the Rich Media Technical Working Group back in the day, and Stuart Galt of Boeing, who chairs both the 3D Technical Working Group and the 3D Liaison Working Group, and Ian Curington, who's an independent researcher in 3D PDF and a guru in the PRC data format, 3D model data format. And what we're going to do is I'm going to run through a relatively short slide deck, framing the context and challenges as I see them. Phil will give a brief demo on validation properties, and then I'll talk more about the rocks that we're considering for this particular stone soup, and talk a little bit about what ingredients might help bring out the flavor. And then we're going to, once the slide deck is done, then we're going to have the panel discussion. Then before we begin, there's a few things that I want to mention in terms of helpful context. I'm going to be switching possibly between ECMAScript and JavaScript. ECMAScript is the official term, JavaScript is a legacy term, and they basically mean the same thing, but keep that in mind as I do that. And then the other thing is optional content. This is also known as layers. It's often used with 2D PDF content to toggle on and off the rendering of different page content. And that's what I want to bring from the 2D PDF world into the 3D and PDF world. And then thirdly, I do want to talk a little bit about my background in illustrations. These are pretty obviously generative AI interpolations of different visual ideas. But the unifying theme is extrapolated visions of the future from different eras rendered as modern engineering drawings. Generating these was an interesting experiment, but interpolating these different visual ideas does not necessarily make for good engineering drawings. And so keep that in mind and be gentle when you see them. They do, yeah, that's all I want to say about that, really. But I thought that was interesting and good visual type thing. So let me switch to the next slide. If I can get to the next slide. Here we go. So why change how we do 3D in PDF? I think basically it comes down to we don't engineer like we did in the 18th century. We probably won't engineer in the same way in the 22nd century. But engineering is a living practice, and we want to evolve our tools to better meet the challenges of today and tomorrow. And an important role of 3D PDFs isn't just as a medium of exchange of 3D data, but also as an archival of engineering information. Engineering drawings aren't just for engineering, they're contract documents, and they can have multi-decade lifespans. So it also makes sense to think of them in the context of PDFA and how exactly they meet PDFA standards. There is a carve out in PDFA 4E that allows JavaScript to be used with embedded 3D models. But if you consider PDFA about being viable documents decades or centuries into the future when today's tools have long been forgotten, Do you still have the means to treat that file as a complete document if today we only have one vendor that completely supports the 3D ECMAScript technology stack? So, so the current state of 3D PDFs right now. There are now 4 data formats for 3D models that can be embedded in PDF per ISO standards. In practice, I believe that we're still at 2, but in theory, almost any 3D model or data format could be embedded in a PDF, rich media annotation. The trick is finding a viewer that understands both the 3D data format and the PDF. And the current vendors that generate 3D PDFs, in my opinion, have brilliantly used the tools available to create usable documents, but they chafe at the limits imposed by the workarounds necessary, including performance limits. On the PDF viewer side of things, it only works for one specific vendor's products. It makes it difficult to maintain. And for other vendors, it makes it extremely difficult to exactly match the one vendor's behavior. Um, in short, I think we're at a local maxima, and we need to climb down temporarily if we want to reach greater heights with our tools. And potential benefits are that we don't necessarily need to rely so much on ECMAScript in order to create 3D and PDF documents. And to be clear, we can't completely eliminate JavaScript from 3D PDFs because it's part of the PDF specification, has been for almost 25 years. And we can't change that with our philosophy of how exactly we maintain PDF documents. However, we can modify how we create PDFs so that ECMAScript is not the central pillar upon which everything else relies upon. I think we can augment the PDF specification in small ways so that the fundamental problem of too much information in too small of an area can be addressed in other ways besides resorting to JavaScript code. So, as a preliminary list of ways that we could change how exactly we embed PDFs or we embed 3D models into PDFs and interact with them. I have in mind 4 small discrete projects that could be more than the sum of their parts. And there are possibilities beyond these. One of our panelists, Ian Curington, actually suggested 2 more earlier this morning. But as a start, highlighting of 3D nodes controlled via optional content, making it so you can on the click on the screen that shows a 3D model and get back a 3D node-specific action so that a click on a node could show or hide contextual information through set optional content state actions or go to 3D view actions. Third, surfacing embedded metadata to the page. If you basically via a new type of annotation that would also be subject to optional content controls so that you could make room on the page for other stuff if you don't need that particular information on the page. And fourth, we also want to embed validation properties into PDF metadata in a 3D format agnostic sort of way. And like I said, this is just basically just the start of the ideas, but want to go a little bit more into what that last part, validation properties, would mean. And for that, I'm going to turn it over to Phil to sort of present his view on validation properties.
All right. Thanks very much, Patrick.
Mm-hmm.
All right. So I'm going to talk, I kind of just jumped straight into validation properties, but let me just talk a little bit about what they are first. Validation properties are a way in the mechanical space that we put information into a file that gives the reader confidence, trust that they read the entire file. So when we write a file, we put in validation properties saying that, hey, I wrote, let's say it started in the STEP community. So when you write a STEP AP242 file, you write information about the data that you put into that file. And then when somebody else reads it, they compare what they read with the information as what you wrote. And what that means is we know we're validating all the exact same things, right? And we don't have that today in PDF. There's a need to validate 3D PDFs. They're almost, I would actually say all 3D PDFs are derived content from typically a CAD model in the engineering world, anyway, a CAD model, and they'll create a PDF from that. It's important that you know that the PDF is accurate to your source information, and that's this validation process. The reason that we're asking to talking about doing these validation properties is just to do exactly what it says here: trusted digital definition. If we can put validation properties in it in the file, then we have a way of digitally determining that we're validating the exact same properties. Next slide, please.
Mm-hmm.
So there's a couple of pillars we're going to talk about. And the first one is this one. Sorry, it's a little bit unformatted. Is to ensure the digital shape is the true shape. So making sure that all the model geometry is exactly like what you had in your authoritative source CAD, making sure that the visualization of that is exactly the same. And so, as I mentioned, we're going to, in the originating system, they're going to calculate some properties. They're going to store it in that PDF file. And then when it's read by a product like Acrobat, you could then compare those validation properties against the source and make sure that they're the same. Or actually, in our software, what we do is we compare. There are validation softwares. Elysium makes one. There are other companies who do that can compare these two things. And when we read that source data validation properties, we know that the expectation is that what we validate will meet those same properties. So we need to make sure that we validate the same number of objects, that we validate the same properties, et cetera, that were written into that file. And then when we're done with our reading of transforming the PDF or reading the PDF, we would know for certain that it matched that the CAD system. Next slide. We're going to do that by storing a bunch of different validation properties. And there's a group called the CACS-IF. And what that is, it's ran by a number of companies. PDES is the company in the United States. And they have specified what validation properties you need to put in a step model. Our proposal is that we use those same validation properties when we put validation properties in PDF. I think that if we do this, that schema then could be used for any visualization format that is derived from CAD. So you could put the same types of things into a GLTF file or a JT file or an HTML file, and it would give you confidence that you're validating that your derivative file matches your source file. So they have defined validation properties for solids, for surfaces, for curves, and for points. And we store that data in there, and then when we read it, we know that we determine what we read, we compare it with those properties, and we know that it's the same. Next, please. The second one is the machine manufacturing intelligence, and that's what we call product and manufacturing information. That tends to be the geometric dimensions and tolerances, notes, any type of data that refers back to the geometry that gives you manufacturing information. They've also defined a number of validation properties that allow us to validate that too. So we validate the form using the first pillar. Now we're going to validate the manufacturing and the product manufacturing information. Next slide. And then we're going to look at doing that in two ways. They do that in the CACS-IF. The first one they call the semantic representation. That is the data that defines that PMI. So if it's dimension, it's going to have you're going to have the points that you're dimensioning from and to. You're going to have the actual dimension value, those types of things in there. Then we also validate the graphic representation or presentation of that. So you have the semantic data, what the actual parameters are used for a piece of product and manufacturing information, and then that gets converted into something that gets displayed with leader lines and everything else that's associated with PMI. And that's what we call the graphic representation. And they have data for validating both of those things. So you're certain that the derived format matches the exact PMI or other manufacturing information that you need to validate that it's accurate to your source model. Next slide. Yeah, and then we think that and the CACS-IF believes that if you validate both these two things, that you have a high degree of trust that it matches exactly the authoritative source, and that you're visualizing your manufacturing off that same representation, and you know that you get the same authoritative information that the designer intended. All right, next. And then here is just a simple workflow, same thing, where you have in all technical data packages, there are two parties you have to consider. The one is the sender. They create that technical data package. And typically, it's a PDF file. And then that's where the validation properties get written. And then you're going to send that to somebody in the receiver. When they open that, they can check to visualize that. They can check to make sure that they're visualizing the exact same data as it was written. All right, and that's it for what I have prepared for today.
Okay. Thank you, Phil. To go back to sort of the whole idea for the different small projects, for this slide, what I wanted to think out basically the process for creating PDFs with these extraneous features that aren't quite, they're not in the PDF spec at this point, but could be in the future, because it is a little bit more complicated than just shoving a bunch of code and data into a JavaScript stream. But it shouldn't be too difficult if it's done in the right order of create a template, extract the data from your CAD system, identify the set of 3D nodes you want to highlight, create and augment the optional content configuration specific for that 3D model, create the annotation, and then have maps for the optional content groups to 3D node sets and additional action to map clicks on the nodes to toggle optional content. Then finally, import the other metadata as XMP streams and regenerate the appearance for metadata display annotations. And I want to point out that this isn't necessarily cast in concrete. It's not completely fleshed out or how exactly we want to do this, but I think it shows that it is possible to create such documents without making it too difficult to do so. So the next step is talk about our stone soup. Who would be contributing to it? It could be you or your colleagues. Maybe people with experience in 3D formats or CAD systems. Maybe developers. It really doesn't matter so long as you have an idea of you want to collaborate from small contributions from many people with different diverse talents, rather than relying on one multi-talented master chef to create a master recipe for us. And I think that's doable. So why join? Why consider joining this effort? Why consider contributing? Give out a bunch of reasons on this slide, but it's basically you have something that you want to help in this effort to make the tools for the future. Please consider joining us. And in terms of how, like I said earlier, this is a PDF association project. We have 3 different groups that are basically involved in this sort of thing. So the division of labor is validation properties is a 3D technical working group project. Enhancements to the rich media annotation would be done by the rich media technical working group. Requirements and interfacing to the broader 3D engineering community would be the 3D liaison working group. Metadata surfacing to the page level would probably be done by the rich media. But really, we have ideas that float back and forth between these 3 groups. And I think joining any one of them or all of them would be a valid way to contribute. And we have our meetings coming up in March, really, if you want to think about this and join. Doug Johnson can probably speak a little bit more about the technical aspects of joining the PDF Association to join this effort. But I think, yes. So thank you for your time and attention. And I think we're now going to go to the panel part of the discussion. And Duff, it's over to you.
Great. Thanks to you all for that presentation. Now we have the Q&A segment, I guess, of our webinar here. And we're going to start with a question that we've received. This was directed to Phil. Phil, a questioner asks, I thought you mentioned a model difference compare chances tool. Can you say more about that?
Yeah. There are definitely products out there that can check to make sure that the PDF information that you have is accurate to your CAD information. Our company sells one, and I think there's other companies that are maybe members of the association that also do. And that companies typically use that to ensure that the visualization derivative is accurate. And then for things like long-term archiving or FAA certification, that you typically need that validation report for your PDF to ensure that it's accurate. So it's a well-known process to do that. And we think that the validation properties are going to help us to make that even more accurate to ensure that there's not data that's in the file that maybe we're not reading directly out of that file.
Okay. Let's see, we have another question here. So maybe this goes back to some the basics, I guess, here. Why do we have to talk about 3D in PDF without JavaScript at all? Who wants to take that one?
Yeah, I'll go ahead and I'll take that one.
Sure, Phil, you do it.
So the reason that we're looking this as a group is that JavaScript is one of the largest security vulnerabilities for PDF, and I think there's been a number of studies that have been shown that. And the PDF associations work very hard on making sure that we make PDF as secure as we can, and work with a number of agencies to do that. But with this JavaScript in it, you have code that gets executed at runtime, and that code can be easily altered, or if you're not careful with your PDF files, you can somehow get a security vulnerability as a result of that. And what we're trying to do is we're trying to remove that from the PDF ecosystem, right? Making it more secure so that you don't have these unanticipated runtime behaviors. And if we do that, we think we can get, for 3D for sure, the same behaviors that we get today with JavaScript by defining it in the form field. So you declare what the form field does, and you don't need to write JavaScript in order to make it do that. In the current environment, the way that you get things like cross-highlighting work, I click on a dimension and a surface highlights. The way I do that is by writing some complex JavaScript. It's going to listen for the event. I get a click. I make sure, oh, it clicked on this dimension. What's this dimension associated to? I'm going to need to go over and I'm going to have to highlight that. That's all done in JavaScript today. What we think in the future is that when you create that form field, the form field is going to know it's an associative form field. It's going to listen for that click, and it's going to know that it's going to highlight another piece of geometry as a result of that. So you get more intelligent form fields that don't require that JavaScript scripting. And we think we're going to be able to get the same behaviors in a more consistent, more secure way.
Okay, thank you. Again, remind our participants, feel free to ask your questions through the Q&A pod. Next question. What other use cases for 3D content in PDF are there? And why is PDF, in fact, so critical? Because for most people thinking about this, over here is 3D, and that's sort of dynamic. You can turn it around and spin it and zoom in and out and change layers and do all this fun stuff. Over here is PDF, and PDF is kind of static and so on. So why is PDF so important to the use cases for 3D content? Perhaps
I can take
Ian
that.
can take that.
I think the use case for combining 3D inside of a PDF really comes down to enhancing the communication of what is in the 3D model. It means that you can have the three representation, the visualization of the 3D model in context with all of its other relevant information, all within the same wrapper or document. And the fact that it's in a document, it's also very powerful because it means that you can view it offline, archive it for future readers of that document, and also keep it safe by encrypting it or making sure that all the information required to both view and understand why it was created or what you should do with that model is all in the same place. That's not going to be lost in the future when a domain name shuts down or a website goes somewhere else. It's not so fraught with the longevity of dynamic content that we see on the internet today. And it also means that it's quite a broad spectrum of 3D models that could potentially benefit from that. In manufacturing, clearly being able to have precise information so that a subcontractor could create a part designed by someone else, or for that design to be signed off by management or part of a contract. But it also means things like industrial inspection, where someone goes on a site or an insurance adjuster or someone evaluating the safety of a particular hazardous plant could go in and take model data from that plant, embed that in 3D in a report, which is also then signed off as we now certify this plant to be safe for particular activity. So it covers quite a broad range from engineering analysis, geospatial data, even medical health data, 3D models of organs, quite a wide range of things.
Thanks, Ian.
And
Others
Ian,
want to
Ian,
address that?
yeah, just real quick, Ian, I've seen some examples from you in oil and gas, right? Geospatial
Right.
types of things as well. So the thing about it is, it's this really robust engine inside of a PDF file, and it's always fascinating when you tell people that PDF files can contain 3D. They're less shocked by it today, but there's still a lot of people who are very surprised by that. Um, and it's on every machine. There's a reader of some sort on virtually every machine, that people use in their work environment. And so if you're in a secure bunker in the middle of Nebraska with a government, machine, 99% chance that you're going to have a 3D viewable reader on that machine, and almost 100% chance that you're not going to have a manufacturing or a CAD system or something else on that machine.
Right.
So it definitely, like Ian says, it's about the communication. The largest communication base there is for documents is arguably either HTML or PDF, and PDF is the clear winner in terms of not needing to be connected and being able to view everywhere.
Yeah. I do have some more questions here, so I'll get to this next one. An attendee asks, the DoD and many other security-focused orgs have already made decisions over time that JavaScript is not JavaScript, and I guess they mean the security concerns regarding JavaScript is not so much of an issue. It was instead determined that it's more important to focus on control and handling of the document rather than on the JavaScript itself. What happens? Well, so I'd like to hear your answer to that, and then maybe I'll cover the second half of the question next. Stuart, would you like to speak to that?
Sure, I can. Sorry about the background noise, but yeah, I think that the JavaScript is important because it allowed us to get the functionality that we needed at the time. And I agree that it's less of an issue if you control your environment very tightly. But in non-controlled environments, I think that JavaScript is probably a little bit more of an issue. Going back to Phil, where he talked about if you're offline somewhere in Nebraska, you might not be as worried about running JavaScript because every step that file has gone through has been very, very controlled. In other use cases, for example, if I was working with subcontractors and putting things out for bid and got things back, I'll have a little bit less control. So I think it's more of a moving towards the future. I think JavaScript has certainly played an important role. It's going to be here for a long time because a lot of these documents have a very long lifetime.
We'll
But
get to that.
eventually we'll get there where we might not need it.
And we had a quick discussion about that this morning as well. And it's not 3D. 3D is not the general use case why PDF is moving away from JavaScript, right? It's the general use case of the other use cases for PDF where they want to remove JavaScript from the PDF file. 3D is just a high usage case of JavaScript, unfortunately. So we need to plan for the future, the JavaScript-less future of PDF. I think that's a really good thing because all these behaviors that they didn't think of in the first go round for PDF, right? So almost everything you use JavaScript for today, a reader could have put a requirement in for that and done that in the reader. They just didn't know what all the requirements were at that time. I think we have a really good idea of how people use 3D PDF today, and I think it's a good time for us to take a look at this declarative mechanism and ride that wave while still continuing to support JavaScript for the existing use cases for PDF and 3D PDF. And hopefully sometime here in the not too distant future, there'll be a tipping point where you have very performative ones that are the declarative form fields, and then the JavaScript ones are the older ones that we use. Mm-hmm. So I think it's going to be a good thing for us. It's not necessarily the highest. If we were looking at 3D PDF, would it be the highest priority for us? Most likely not, but it is the direction of PDF, and so we're going to ride that wave.
Yep. So that brings me rather naturally to the second half of the question from this attendee. What happens then if in this post-JavaScript future, what happens to the millions of 3D PDFs that already have JavaScript in them that have already been stored and secured for future needs?
I can go with that. I think the philosophy behind PDF is that we still support PDF 1.0 documents, and we'll continue to support those PDF documents that have 3D embedded with them with JavaScript. But I think what you might find is that the subset of tools that actually actively support that particular subset of PDF features will stay small. And really what we want to do is grow the ecosystem so that more PDF viewers can handle 3D without having this whole JavaScript tech stack, which it was a maintenance nightmare for security issues and just for technical reasons as well. So I think we'll still support the tools that support it. We'll continue to support it as long as it's viable, and we will do our best to continue to support the tech stack that we've inherited for doing that. But I think we want to grow the ecosystem really rather than focusing on the security issues per se that may not necessarily be applicable to somebody's own particular environment, but might be applicable to others, to summarize what other people have been saying.
Yeah, and I would say too that backwards compatibility is it's a great thing to be concerned about. I will say the PDF community is the most backwards compatible community I've ever been involved in, right? You can You can open up PDF files from very long ago in the current reader, and they made that commitment. So I can't speak for any of the vendors, but my expectation would be that your current PDFs would continue to work in the application you're using today. And I highly recommend that you have that conversation with your vendor as well, because they'll definitely have some input on that. But I'm very confident the backwards compatibility will continue to be a priority for 3D PDF in the future.
Anybody else want to take a shot at this one? Okay. So next question, and Stuart, this might be for you. It's great to see support for STEP. Can you talk more about how you support STEP? And I guess that might also be in the 3D PDF context.
Yeah, one of the mechanisms for PDF is there's an extension process, and STEP is one of the 3D formats that was added as an extension to the base 3D, or sorry, the base PDF standard. And I can't remember when it was, but several years ago, we talked about what it takes to implement and using a step model and then mapping it to the internal display tree of a PDF document so that it could actually be done. We had a couple of demos where people did some things in the lab, but as far as I know, it's not a commercially viable product yet. And I think it's one of those things that we need, kind of the chicken and the egg thing. We've shown that it's possible, and it's actually, an allowed, approved way to do things if you want to. But we really need to have some people with the users' requirements saying, "Hello, vendors, I need this actually supported because I want this format as opposed to one of the other formats." The other format that is also there, it wasn't asked in the question, but that's a GLTF. That's gaining a lot of popularity now, and it's got some like I said, maybe not quite commercial implementations yet, but it's also showing quite a bit of promise as well.
So there are now ISO technical specifications that were published in support of both the STEP and GLTF in the PDF context. So what do you think is holding up implementers out there?
I'm not really sure, other than it's you kind of need a critical mass. I mean, you need to have enough. I mean, from a business perspective, you'd need to have enough there so that it would justify people spending the money to support it into their viewers. And so talk to your favorite viewer vendor and say, if that's important to you, ask them about it, because they keep track of that sort of stuff, and that's how they guide their development.
Yeah, and I think there is some, like you mentioned, GLTF. I think is being adopted by Foxit, for example. I think the other thing is that the new viewing formats are also based on PDF 2.0, and that's the first step, right? Is converting people to PDF 2.0, and the current 3D vendors are not producing PDF 2.0 documents. So that's the first hurdle before you get over any user other types of things with it there. But certainly it is the viewers and anybody who I would suggest that people talk to their viewer vendor as well to determine what their plans are for it. There's a new standard that's coming out that's being worked on primarily in Europe. It's called the digital data package. And in this digital data package, PDF A3 is being used as a container for it. And in that, you can have basically any geometry representation and any visual representation as well. So I think if you begin using some, making sure that you're including STEP, maybe not as part of your viewable, but make sure that it's in your technical data package, and understand how you would do that in a digital data package world in the future, I think you can use your PDF now to kind of set you up for that in the future. But the adoption I don't think the adoption has been what we we were hoping for with STEP inside of PDF. And I don't expect that it will be, but I do expect in this new digital data package in the future that STEP will be a very important component of that, and you'll probably see STEP viewers and other things that could allow that.
Certainly the movement to PDF 2.0 is also a challenge. It's a challenge, I guess, even before you get to the question of what you're going to support in addition to that. So that's an interesting point. The next question, does 3D PDF with JavaScript even qualify for long-term archive? Which PDF standard do they fit in? Who wants to take this?
I can take it.
Probably.
Or,
Well, I'll make a quick comment and then I'll let Patrick go.
Mhm.
3D PDF with JavaScript is officially supported as one of the use cases in PDF A4, and PDF A, which is for archiving, is largely thought of as what you would use for a stable, self-contained document format that's expected to have a long life cycle. In my world, we have requirements for records retention and, measuring in multiple decades, sometimes lots of decades. I hesitate to say centuries because I won't be around then, but it's at least many decades. Go ahead.
Yeah, just to tack on to what you're saying, PDFA4E is the flavor of PDFA that's basically about long-term archiving for engineering documents. And there is, like I said earlier in my presentation, a carve-out for JavaScript in PDFA4E. And I should also point out that PDFA4 is the PDFA specification for PDF 2.0 documents. So it is a bit of a transition to go from PDF 1.7 to PDF 2.0, but it is not actually that bad comparison. And then once you move to PDF 2.0, then you can use PDF A archiving standards and meet those. And there is an exception for JavaScript for 3D PDF, 3D and PDF for PDF A4E documents.
Yeah, sorry for talking so much. I'm going to just tag on here a little bit. Archiving means something different to everybody, right? And when I first noticed that was when I started participating in PDF standards. And we were talking about archiving in an engineering perspective, and they were talking about archiving in a librarian perspective, right? Or a historical relic kind of a way of looking at archiving. And the first three PDF-A standards were all built around the historical archiving community in my impression of what we did.
That's fair.
When we got PDF-A4, we thought, we need something different. We created PDF-A4 that has a conformance class for engineering. That's one use case. The other use case is like when you have to submit like to FAA, when you go for certification, they require an archivable format, and that's almost always PDF for that, or in a low tar, which is used predominantly in the aerospace and defense industry as well, when they archive for those reasons, for when they archive their design. And the reason they need that, right, is because if a plane goes down, but it was manufactured 26 years ago, you need to know information about that so you can go back and figure out why that is. I think that's why they do it, but that's maybe one use case for that. In those cases, PDF is still a very good archival format because it's a completely published format, right? So everything about it is an published open standard. Even if you have a reader sometime in the future that doesn't open it, you can definitely you can definitely find out what's in it by using the standards-based documents in order to interpret that. So it will continue to be a very good format for archiving, and it's a living standard. It's an active standard that we continue to work on and evolve over time. So I think it's a great archiving standard today. It will continue to be a great archiving standard, I think, in the future.
So just to clarify, I think what's been said here is that there is an archival story for 3D PDF. and that moves beyond, as you put it, Phil, the library kind of conception of what archiving is. However, that was introduced into the PDF ecosystem with PDF A4, and PDF A4 is how you do archiving of PDF 2.0 documents. Whereas as you've also said, up until this point, most of the world, or certainly most of the world doing engineering work with PDF, is still using PDF 1.7. Is that fair summary?
Yeah. Yeah, and I think everything that gets archived today in 3D PDF is a 32,001.
32,000 Part 1, which is the
Yeah,
ISO standard for PDF published in 2008.
right.
Yeah,
Right. And I don't think that in the archival community, PDF-A is a requirement for 3D.
right.
So it's 32, like when you low tar a PDF file is going to be a 32,000-1 compliant file.
Yeah. Ian, did you have something to add? I think you maybe did. No? Okay. So there's a related question then, a comment about PDF 2.0 that sort of dovetails to what was asked before. If existing 3D PDF with JavaScript and multimedia are saved as a PDF 2.0 compatible format, which I guess means PDF 2.0, a lot of data is lost, and I'd be happy to know if that's not correct. What? Any of you want to speak to that? 'Cause I have a question about that question.
Yeah,
Um,
maybe that's a tool specific thing. I think from a format specific thing, there's very few. Going from 32,001 to 32,002, there were very few things that got deprecated, and
Right.
very few things that would have affected 3D. We actually mostly enhanced 3D going from 1 to 2. So I think that may be tool specific, but I'd be happy if anybody wants to reach out and see after this to talk about what they see. We'd be happy to look at that.
Okay.
mhm.
Okay. Next question. Our is the says consortium. I think I guess at this point they mean the PDF Association, looking at formats like USD and QIF and how and if they impact positively or negatively the future of 3D PDF.
Yeah, I don't think we've looked at those specifically in that. Certainly, what we're talking about right now in this group is things like if we do the schema based, let's say with the validation properties are going to be a metadata schema that's going to get attached with a requirement is my expectation. So we're going to define how you attach things in a 3D PDF I think in the near future. We will most likely look at QIF and all the file formats that you can attach at that point for a technical data package. I don't think that there is a need to put them in as a 3D source like we did with STEP into a rich media annotation, because again, that's going to have a requirement on the viewer to adopt that so that whether it's Acrobat or another viewer, when they read that data, they can display that data. And that's not been a successful adoption path so far. So I think that as we look at these new formats, I think we should look at them in the use case of a digital data package, which also has a big PDF component. That PDF component is a PDF A3 file, and they begin to distribute your data. I think it's the way everybody should be thinking about their technical data packages for the future, because it's going to allow you to have a data package that has your entire digital thread all the way from systems engineering through retirement at the end. You're going to know all the data about it. But that's a long-term project. My recommendation is that we look at 3D PDF. You begin to structure your 3D PDF technical data packages in a way that get both your organization and your user base ready for these digital data packages in the future, and which will still have a PDF component. You can have a 3D PDF as a viewable, right? But you're going to have your technical data package is going to transform to a digital data package. And I think it's always going to be, and there's going to continue to be a PDF portion of that. And I think that one of our user groups, like the liaison working group or something like that, would be a really good place to, participate that and help us to, design that transitionary phase and write best practices and other things around that.
I
Anybody
could
else like to?
I
Yeah.
could probably comment a little bit on USD. I think that's potentially an interesting format. It sort of sits in a line similar to GLTF in the way it potentially could be used, or the kind of information that could go in that sort of 3D package. I'm not aware that the association or the 3D PDF community is looking actively at USD at this time, but just be aware there's always a way to take a set of attributes or content containing 3D scenes like a USD and put those as an attachment inside of a PDF. The viewer may not handle that natively, but you can always have it there to be recovered at a later date. And potentially you could transform a representation of that scene into US or GLTF or the existing PRC standard and have that as a preview concept.
Thanks, Ian. Okay, I have one more question here. This sounds like companies with highly evolved and complex 3D PDF templates, including significant JavaScript development, will be facing limitations in the future. What would you say to that?
I
Sure,
would
I'll take that.
expect that. Again, we can't speak for the vendors, but certainly there's no plan to remove anything from any of the JavaScript standards or anything from 1.7. And to the best of my knowledge, there's no plan to remove anything from the viewers that view 3D PDF as well and process the JavaScripts for that. So if I would very much suggest that you have that conversation with your vendor, but my expectation would not be one that you have to panic about that or that there's going to be problems with that. And again, PDF, we've gone through this, right? We went through this in 2009 with 3D PDF, and we're still supporting 17 years later, right, where it's still actively supported in a very valuable format. So it has a long history of being supported, and I don't expect that to change, but I would definitely discuss that with your vendor.
Okay. I'd like to add a little bit to that, is that the whole goal of this project is not to prevent other companies from developing solutions with the tools that they currently have if it's appropriate for them. But what we really want to do is create a path of least resistance to supplement the existing methods of doing things so that more people can participate rather than to put limitations on any vendors as to what exactly their solutions might be. So that's my perspective.
Yeah, and I guess from my side, I would add that, and Phil mentioned this earlier, part of PDF's value proposition is its backwards compatibility story. And so once upon a time, a decision was made to include 3D PDF, and in the context of JavaScript to pull the levers and push the buttons in that 3D data within the PDF context. That decision was made. It's really goes kind of against the basic primary value proposition of PDF that would all of a sudden go away or even gradually go away. So I think it's quite likely that existing levels of support are going to remain. Again, as Phil said, I'm not speaking for any vendor here. I'm just with the association, but that would be the suspicion based upon the whole kind of idea of PDF, frankly. But as Patrick said, it's the future that we're looking at, and the additional capabilities, the new things that people are looking for, and that is probably going to be in terms of the feature level is going to be a PDF 2.0 based world, and it's going to be a world that includes other that may indeed include other capabilities and ways of achieving those results besides JavaScript. And that's what this webinar is And in fact, the activities of the Rich Media Technical Working Group, the 3D PDF Liaison Working Group, and the 3D PDF Technical Working Group, that's really what they're all about. We have another question here. Phil, I know of several companies that could use step support for 3D PDF. Oh, they're going to give you a call. So I guess that's from someone who knows you. Okay. Let's see. I don't have any other questions at this point. Are there any other kind of closing statements that you all would? Oh, there is another question, just showed up. What is the formal position of Adobe on this initiative? Vendors can do many things for business opportunities, but we have not heard much from Adobe. Understood that they are not the only PDF reader option, but their backing would be important. Well, none of us can speak for Adobe. None of us work for Adobe, and Adobe's not here to present for themselves. So I don't think we can speak to their formal position, can we?
No, but one thing I would say is that this, we call it forms.next. This is the declarative forms. That was seeded by Adobe, right? So that was, they started that process inside the PDF Association.
Right.
So if we want to look to support for declarative forms, I think that their actions show that they are very interested in it for certain. We can't speak for them, but certainly they were the ones who proposed that.
Yep.
Mhm.
Okay. All right.
Do have one question for you, Duff.
Oh, yeah.
If anybody is interested in taking part of this thing and they're not currently a member of the PDF Association, how do they go about joining this effort?
Yeah. Excellent question. So the PDF Association operates like 20 or 21 different technical and liaison communities, and you can find these at pdfa.org. Go to the working groups menu, and you learn all about those different communities. 3 of those communities are involved in these questions that we've been discussing in the webinar today. Patrick, who's the chair of the Rich Media Technical Working Group, launched this webinar with the idea to begin to look into these particular questions of what might be the future of 3D PDF if JavaScript wasn't involved in that future development. But there are 2 other working groups within the PDF Association that are specifically directed at and focused on the subjects of 3D in the PDF context. One of them is for vendors in the space. That's the 3D PDF Technical Working Group, and that's very much focused on the format itself and solutions and problems associated. And the other working group is a so-called liaison working group, which is more designed for the purposes of the kind of large-scale implementers or customers of 3D PDF. And that forum is really a place for the stakeholders in 3D PDF to come together to talk about their needs. And it is used in a sense as a place where we would develop questions and ideas and concerns that would then go to the technical working group for discussion at a technical level, resolution, and then hopefully development with the new guidance, new application note, perhaps potentially, and even potentially extensions or enhancements to the international standards for PDF technology itself. So 3 working groups within the PDF Association that pay special attention to these subjects, and that would be that would be an excellent way for stakeholders out there to get involved in these exact discussions. So if that's good, I don't think we have any more questions in front of us here. So absent that, I'd like to thank you all, Patrick, Phil, Stuart, Ian, for participating in this webinar. I think it's been very informative. And for those who are wondering, this webinar is being recorded, and we will be posting it so you can come look at it sometime thereafter. Thank you once again from the PDF Association, and hope to see you at another webinar. Take care.